So we're going to take a look here at the solutions to your confidence intervals for proportions review sheet. So here in this first question, for part A, where you're talking about the confidence level, this is where you're talking about the long run success rate. So I would say something like, if many intervals were constructed using this method, about 95% of them are going to capture the true parameter. But I want to make sure that it's in context. So I would say it would capture the true proportion or the population proportion of households that own at least one dog. For part B, in order to assess this 39% claim, we want to see whether or not that is consistent or inconsistent with our interval. So because my interval here is just written as my estimate plus or minus a margin of error, I probably want to calculate those endpoints to get that lower and upper bound. So my lower bound would just be 0.417 minus the margin of error of 0.119. So it'd be 0.298. And then my upper bound would just be 0.417 plus the margin of error of 0.119. So that is 0.536. So I would say that I'm pretty certain that somewhere between about 29.8% and 53.6% own at least one dog. So 39% is within that interval. So 39% is a reasonable claim. So it does not give me evidence that it's different from the claimed national proportion. And then finally, to figure out how many households were in the Humane Society's sample, I can use my margin of error to figure that out because I know that my margin of error is equal to the critical value z star times the square root of p hat times 1 minus p hat over n. So here's my margin of error, the 0.119. Z star for 95% confidence is 1.96. And again, I can get that from table A or Stablet. And then p hat is the 0.417. And so in order to solve here, I'm going to go ahead and divide both sides by 1.96. And then I want to square that result to get rid of my radical. So if I divide by 1.96, that gives me 0.061 roughly. And then I can square that. That gives me about 0.0037 is equal to 0.417 times 1 minus 0.417 over n. So that would be 0.243 roughly here over n. I do have to be careful here. The n is in the denominator. So think about it like multiplying both sides by n. And then I would have to divide by that 0.0039. So I have 0.243 divided by 0.0039, which is going to give me n equals 65.95. So it was probably 66 with the rounding. And then finally for this one, to construct your 99% confidence interval, we do need to make sure that our conditions are met. So here it told us that we have a random sample. And then we also have to check the n times p hat and n times 1 minus p hat are both at least 10. So it said 26% answered correctly. So I have 9,600 times 0.28. And then I also need to check n times 1 minus p hat. So 9,600 times 1 minus 0.28. Those are both going to be at least 10, but those values work out to be 2,688 and 6,912. So those are both at least 10, sampling distributions approximately normal. So then to calculate my interval, it's p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. So p hat here is that 28%, so 0.28 plus or minus the critical value for, hang on, it's covered here on my screen, 99% confidence. Again, we can get that either from table A or Staplet, is 2.576 times the square root of 0.28, 1 minus 0.28 over 9,600. So if I take that radical and take 0.28 times 1 minus 0.28 over 9,600 and take the square root, I get about 0.0046. Which I then need to multiply by my critical value. So times 2.576, I have 0.28 plus or minus 0.0118. So again, then I subtract that from 0.28. So 0.28 minus 0.0118 is going to give me 0.2682 for my lower bound. And then if I do 0.28 plus 0.0118, my upper bound is 0.2918. So to conclude in context here, I would say, this is my interpret part, I am 99% confident that the interval from 0.2682 to 0.2918 contains or captures the actual proportion of students who correctly answered the question.